good? No, I'm good.
All right, everyone, please give a round of applause for Andrew Kamal, a talk on Stark drones, changing the way the world communicates.
Hi, my name is Andrew Kamal. I'm the founder of Stark Drones, and Stark Drones also has a CubeSat and internet connectivity startup with done a DBA as Starkcom Global. So a few facts about me, Coptic Orthodox Egyptian. I spoke at Maker Faire Detroit 2017, 2018, 2019. This is actually my first global speaker fair to speak at. And my favorite foods are shawarma and all types of candy, a quote-unquote little known facts. I'm obsessed with pugs and Egyptian cats, especially mules. So the problem that I'm trying to solve is a third of the world is unconnected to the internet. And I'll go more on that in a second. Also in terms of emergency communication systems, for places like Artsakhi and with war going on and a lot of displaced Armenians, and then the Palestinian conflict happening in the Gaza Strip, communications is obviously a very critical issue in regards to emergency communication. And besides trying to provide internet to a third of the world, a lot of the internet infrastructure that we currently have offloads a lot of energy and a lot of problems with the grid. So telecom grids and telecom systems widely relies on infrastructure that a lot of society cannot provide. So again, before I present, I just want to say none of this is investment advice or anything like that, not trying to sell you guys anything. I'm just trying to inform you about lots of the tech that we are trying to work on. So in terms of being reliable, the American Society of Civil Engineers gave the power grid a D+ rating, which is terrible. According to Broadband Source, a third of the entire world have no access to the internet as of 2023. And the key holders of the internet is a select group of people, and most of the internet is severely centralized. Right now, the market size of the telecom industry is obviously booming. Like you're talking about potentially a $3.8 trillion telecom industry by 2026, and a $413.16 billion smart infrastructure market by 2028. And Stark Drones is trying to build a lot of solutions and technology centered around disrupting telecom and infrastructure as industries. So we have a lot of intellectual property. We're trying to do a lot with data compression and things like that. But the main thing is how we go about connectivity and actually working on CubeSats. So we build a variety of different networks. So we work on underwater wireless network telemetry. We work on cube satellite systems. And we work on peer-to-peer grid infrastructure. Something, a little known fact is the original prototype versus the fourth prototype. There's a lot of R&D to get to its final forms. But basically, with underwater wireless networks, there's a problem in terms of trying to actually collect data underwater, which is the Doppler effect. And because of the Doppler effect, you can have good wave propagation and signals bounce back and forth. We ended up trying to come up with a communications algorithm that actually translates sonar communication. And examples of what underwater telemetry could be used for could be lightweight IoT networks for beach water testing and things like that. So a problem is a lot of underwater wireless networks, for example, use wet and chemical dry testing methods, and you have to have a chemist or a biochemist and be able to get data and collect samples. When you have a real-time underwater network and you have these IoT sensors, you could get information on harmful cyanobacteria and things like that almost instantaneously in real time. And obviously this is very important because you're talking about trying to preserve and protect our oceans, and it could be used for targeting places for like mineral offloading or detecting harmful toxins in algae blooms. And besides that, the next thing I wanted to talk about, which is the main technology, is the technology that actually relates to actual people in citywide infrastructure, is CubeSat and nano satellites. So a big thing that goes on in trying to connect people is when you have large satellite infrastructure, a lot of satellites are extremely large in size. Usually you utilize rockets in order to bring them past low Earth orbits. They're extremely unsustainable in terms of the launch mechanism. CubeSats, on the other hand, are extremely portable. Lots of them are 5 inch by 5 inch by 5 inch in size. And one thing that Stark Drone's done is we figured out a different algorithm for the Cube satellites in order to provide WLAN, radiosonic technologies and stuff like that. Basically LoRaWAN communications as well, at a cost-efficient way, and we've done that through compressing network packets. So when you're able to compress network packets and look at fuzzy logic through the signal processing perspective, you're able to deploy these Cube satellites, and you're able to not just deploy these Cube satellites to low Earth orbit, but you could deploy them close to local cities using aerostat balloons, which are balloons that are able to have helium and have hydrogen gas, and able to sustain it for long periods of time, and it doesn't revolve rockets or ballistics or even any net negative carbon offsets to deploy those CubeSats and be able to offer telemetry to cities at a cost-efficient price. So launches right now is eventually we're able to potentially do launches with profit margin for $17K per satellite as opposed to over $350,000 and above. And we're also able to even utilize these CubeSats with rideshare companies. So if you wanted to have CubeSats like these to go to low Earth orbit, you could piggyback off of a rideshare like SpaceX or Amazon's Project Kepler. Or if you wanted to go the more sustainable route, you could obviously use internet balloons. And beyond that, you're gonna eventually, because of the cheaper prices, be able to offer internet to these communities at a much more cost-effective price. And you're able to make space exploration and connectivity in general more accessible to the general public. And we're also working on not just making our CubeSats more accessible, but we're working on creating swarm-like capabilities and modular designs where these could connect and interface with our telemetry protocols and our other prototypes. And we've done a lot of tests. So one of the biggest tests we've done was trying to collect telemetry data in Harbor Beach, Michigan, all the way in Harbor Beach, Michigan. And we're trying to collect various forms of data in order to be able to eventually get FAA flyers and bid on large contractual projects to offer internet and telemetry to a lot of small and mid-sized cities, especially in third world countries and in places like Indonesia, where you're talking about like 18,000 islands and not very accessible areas for obvious rocket launches. A solution like internet balloon systems would obviously be way more sustainable. And one of the main goals is obviously connect the unconnected. This is a theme that Stark drones have had for a while. And in terms of connecting the unconnected, there's other things that this technology could be utilized. Protecting our sovereignty is something that this could also be utilized. So something unknown to a lot of people is not just satellites that end up having like spyware or things like that, but there's also like the use of ballistics in war. Something that, in order to bring down an enemy missile in war, a lot of countries use ballistics back and forth, and millions of civilians end up getting targeted, and you have thousands of deaths to bring down a missile. One of the capabilities of our CubeSats events in the future could be intercepting actual communication signal for a missile and bringing it down without the use of ballistics, which would dramatically decrease the loss of civilian life. And we're trying to be very data oriented in the beginning stages of trying to make this technology a reality. And something also that we're working on is we're actually working on compute modules. So compute modules end up having this lightweight LoRaWAN networking capability in it. And Stark Drones have built its own compute module, which I could show you in a minute. We have the compute module here with us, by the way, which is, I don't want to like share it too much, but it has its own like LoRaWAN and Bluetooth connectivity chipsets, and it has a lightweight MCU, And these could actually pair and act as gateways for a lot of those wireless networks that we're trying to do, and the CubeSats that we're actually trying to deploy. And our why is obviously very important, because not only do we want to make societies more connected and we want to solve all these problems, but we also want a lot of this data to become more accessible. We want to both target CubeSats for the hobbyist and engineering market, but we also want to target it for like military and non-civilian applications as well. And we also want to target it for providing aid to third world countries and cheaper methods of telemetry and connectivity, and really being able to send out messages and literature and things that these third world countries might not have ever had access to. This is including very specific literature, because a third of the world didn't have access to the internet. And obviously you could utilize similar telemetry communication protocols and boards for avionics modules. This is also modular, so my goal is to eventually create a grid of a lot of these networks. And I want to work on distributed networking, I want to work on modular connectivity, and I really want to work on bringing the technology that Stark Drones is trying to make and bring it to the mass market and hopefully disrupt society with it. That's my talk. Thank you.
Any questions?